Hello! Welcome to my video about the chemistry of highlighter pens. In this video, we'll be exploring a brief introduction of what highlighters are and what they do, and then talk about how they do it. Essentially, highlighter pens are made up of two types of plastic. Normal plastic on the outside, which makes up a sort of shell in the cap, and a cylinder and pen tip of highly pressed polyester fibers inside the casing, which hold a reservoir of fluorescent dye. Highlighter pens use a special fluorescent dye inside to add a very visible, eye-catching addition to a piece of paper. Their traditional use is to bring attention to typed out words on a page, but I personally like to use them for art and decoration as well. So, now that we know what the pens actually are and what they're used for, how do they do it on a chemical level? Well, surprisingly, it's not just that it's an especially bright dye. There's actually some pretty cool light science going on with the dyes alongside chemistry. Before we get into the specifics, I'd like to mention the dyes that are commonly used and what colors they are connected to. Yellow highlighter dye is usually made from pyranine, which is a pyrene-based dye, or fluorescein. Pink highlighter dye is usually made of rhodamine. Orange is a mix of coumarin and xanthan dyes. Blue is... okay, let me prepare myself. Blue highlighter's dye is made up of triphenylmethane. And lastly, green and purple are both a mix of triphenylethane. Green is a mix of triphenylethane and pyrene, the stuff pyranine is based off of for the yellow dye. Purple is a mix of triphenylethane and rhodamine dye, which gives pink highlighters their color. So, those are all the fancy dyes that work in the fancy way which I shall now tell you. The dyes that are used in highlighters are special compounds that absorb UV light. The UV light excites the electrons inside the dye. These electrons then lose energy because of their vibration, releasing visible light. They work off of the principle that energy emitted must be less than the energy absorbed. Here's a really good chart by Nerd Rage that explains it beautifully. Essentially, highlighters can be bouncing back visible light that's pretty near to ultraviolet. Some colors do this better than others, like yellow versus pink. I think that this is because of the chemical makeup of the dye. Also, fun fact, ultraviolet light isn't actually purple colored. That's why we can't see it. I hope you enjoyed this brief video on the chemistry of highlighters. Now, onto the questions from my school. If highlighters didn't work. Honestly, I don't think the world would lay down and die if highlighter pens didn't work. But, a very cool way of discovering bacteria by putting special fluorescent dyes that react to diseases like E. coli into water samples has contributed to people staying safe with the water they drink. So, I think it would be pretty bad for us to lose fluorescent compounds. Also, I have chosen to highlight the amazing experiment done by Nerd Rage on the super awesome effects of adding 1 microgram of a fluorescent compound to a single sample of solvent. The solvent with the fluorescent compound is then placed in a line of the same solvent but without the fluorescence. Then he shines the UV light through all the solvents and it's very clear to see which one has the compound in it. This experiment also showcases the life-saving use of fluorescence. As I said earlier, some fluorescent compounds can react with bacteria like E. coli. And when you shine a UV light onto the samples with the compound in them, you can easily tell what water has a dangerous bacteria in them. Anyways, I hope you enjoyed learning about highlighter pens and fluorescence. God bless you and goodbye.